Welcome, everyone. We'll just be giving people about 3 minutes or so to trickle in, and we'll get started at that point. Just go ahead and hang tight for now. For those still coming in who might have missed the first one, we'll be just waiting until about 3 minutes in to get started to give people time to come in. Looks like we still have people coming in, so I'll give one more minute and then we'll go ahead and get started. Hi to everyone who's here. Okay, looks like we've started to slow down on people coming in, so we'll go ahead and kick things off. Welcome, everyone, to the Kubernetes 1.31 release webinar. And my name is Taylor Thomas. I'll be moderating today's webinar. Before I hand over to Sriram, Angelos, and Abby, who are the leads for the 1.31 release, I'm going to go through these few housekeeping items that we have. First off, this is a webinar. You're not able to talk as an attendee, but there is a Q&A box or a discussion or comment box at the bottom. I will be monitoring that the whole time and will feed those questions either if there's an appropriate gap during the conversation or at the end of the things they're presenting. So feel free to drop in those questions and we'll get to as many of those as we can during this hour time we have scheduled. Now, this is an official webinar of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that code of conduct, and just basically be respectful to people. And then last, please note that this recording is going to, and the slides themselves will be posted to the CNCF online programs at community.cncf.io. So they will also be available if you register for this via link, or also on the online programs YouTube list after this is all complete. So with that, I'm going to go ahead and hand it off to the team to introduce themselves and kick off their presentation. You want to go ahead and introduce yourself?
Right. Thank you, Taylor. Hi, everyone. Super glad to be doing this. Hi, my name is Agilos, and with me I have Sriram and Abby. I was the release lead for Kubernetes 1.31, and Sriram was the enhancements lead, and Abby was the communications lead. Right, awesome. We have the slides, great. So we're here to talk about the Kubernetes 1.31 release, which was out just 1 month ago. The release name is Ellie. Now, before that, let me again go over the presenters. Let me introduce myself. My name is Agilos. I've been part of the release team since Kubernetes 1.26. So I have been here for some releases now, and I was a release lead for Kubernetes 1.31. My day job, I'm an engineer working on Kubernetes and contributing to quite a few stuff around open source. With that, let me pass this over to Sriram. Sriram, would you like to introduce yourself?
Yeah. Hey everyone, my name is Sriram Venkatesh. I've been the enhancements sub-team lead for 131. I've been part of the Kubernetes release team from the version 129, where I was a shadow in the enhancements team. In my day job, I work at Big Bindery, and I've been active in the Kubernetes community for some time now. Yeah, that is pretty much about me.
Thank you, Sriram. And also with us, we have Abby, who was the communications lead. Abby?
Hi, everyone. Yes, I'm Abby. I'm the comms lead for 131. I've been a part of the release team since 129, working primarily just on the comms team. I am a technical writer by my day job, and it was really awesome being part of this release, and I'm happy to be here sharing this all with you.
Awesome. Great. Thank you very much. So with that, let's go into the first thing I'd like to say is that the release team is not just the three folks that you see here. The release team is staffed by about 30 people, and there's multiple sub-teams. We have enhancements, release notes, comms, release signal docs, and also branch management. And we also have an emeritus advisor. So as I've said multiple times in the release team meetings, I would like to say once again, these are the people that you have to thank for the great release that was 131. All of those people here gave their time, and they did great work to ensure that the release was on track, that all of the tasks were completed, and that no things were left unattended. So I do want to give a shout out to all of those people. Congrats, and yeah. Next up, this is the logo for the Kubernetes 131 release, Ellie. So Ellie is the name of the dog. It's a nice dog. Just 130 had a cat, so it had to be a dog for 131. And who knows what's going to be for 132. I can't wait to see what Federico comes up. Cool. So with that out of the way, let's talk a bit about the enhancements, what's new in Kubernetes 131. We have a total of 45 enhancements. 12 of them are in alpha, 22 were beta, and 11 were stable. There is a link here that basically is a link to the enhancements board that the enhancements team uses throughout the release to track all of the enhancements that go in. And you can go there and see with as much detail as the release team tracks about all of this stuff, pretty much anything you might want. What I would like to talk about, basically what we'll do is we'll go over a list of the major themes of the release. So to start with, let's begin with APM Armor Support, which goes to stable. Pretty much the APM Armor Support in Kubernetes is now GA, which means that when you want to set an APM Armor profile for your workloads, you can do so by setting the appropriate field in the container security context. In the past, this was handled via annotations, which is not anymore the case. Sriram, would you like to talk about the next one?
Yeah, thanks, Angelos. Another change which goes into stable in this release is like improvements to the ingress connectivity for QProxy, and so this enhancements proposal it does this by adding better capacity to drain terminating nodes which are like exposed by load balancer services. Basically, this is in alpha in 128 and it went to beta in 130 and now it is in stable state with 131. Yeah.
Great. Next up is persistent volume last phase transition time. This also goes to stable with Kubernetes 131. So the last phase transition time essentially adds a new field, a new timestamp field in the status sub-object of persistent volume. And basically, this is quite useful to have to be able to measure the time that a persistent volume moves from pending to bound. And this can be used by cluster operators to make sure they meet their SLOs, or they can have a better idea of what is the performance of their storage in the cluster.
Yeah. Now we are on to changes which are graduating to beta in 131. And the first enhancement is NF tables mode for QProxy. So this first came up in 129, and it basically adds an NF tables proxy mode feature kit, which can be used to run QProxy using NF tables instead of IP tables. And using NF tables has a lot of advantages over IP tables in that it is more efficient to uh, fetch the endpoints, and essentially like the entire the packets can be served more uh, efficiently compared to the regular IP tables mode.
Great. Next up are changes to the reclaim policy for persistent volumes. Essentially, this adds a new feature gate, uh, which essentially is a new reclaim policy that ensures that when you have a persistent volume, there were some situations, depending on the order of operations on the persistent volume or the persistent volume claim, that resources were left behind in your infrastructure, leading to leaks and similar scenarios. So this new reclaim policy allows our cluster administrators to avoid such situations.
Yeah, the next change is improvements to the bound service account token. So this also first came up in 129 and is going to beta in 131, and it basically allows to like embed information about the node in which the pod is running on in the JWT token, and yeah, you can request the token which is bound only to a particular node and not a pod. Yeah, that is pretty much.
Great. Next one is KEP 1880, which is also going to beta in Kubernetes 131, which is about multiple service CIDRs. So as people operating larger Kubernetes clusters might know, there's lots of IP addresses in a cluster. There are the node IPs, there are the pod IPs, and also the service IPs. So even though most of those ranges can be adjusted dynamically when a cluster grows, service IPs, the service CIDR was not always is not easy to do because it's currently a static configuration in different Kubernetes components. So with this change, what Kubernetes can do is that after you enable the feature flag, then you can basically dynamically adjust the service CIDR that is available for services in your cluster. Which also comes with zero downtime for the control plane components. This is also a very exciting feature, and it's beta for Kubernetes 131.
Yeah, on the same note as the previous feature, this is also part of the networking special interest group, and what traffic distribution basically does is it adds a new field to your services and traffic distribution field, and it currently takes a value of prefer close. So if you set that value for your service, then whenever a client makes a request through the service, the service will serve the traffic through whichever pod which is the topologically the closest one to the client. And if the value is not, like if the field is not set, then the pod which is serving the traffic would be like the best effort pod. So yeah, this is another interesting new feature from SIG networking.
Excellent. Next one is volume attribute class modify volume, which is moving to beta in 131. Basically, it provides a generic Kubernetes native API for modifying the volume parameters. For example, provisioned I/O. This allows essentially when you have existing volumes, you're able to modify their parameters, their size, to basically adjust for cost. If larger volumes cost more money in infrastructure, so you can adjust them dynamically, and also get better performance if that is supported by the provider. This feature was added as alpha in Kubernetes 129, and it's now going to beta for 131.
All right. Dynamic resource allocation, or DRA, has been an area where a lot of development is happening in Kubernetes right now. And in this release, we have a bunch of new features shipped as part of DRA. Uh, there are a couple of KEPs you can search for in the enhancements board that Angelos had shared earlier, but some of the major changes are adding structured parameters, which makes the request and resource information, which is previously opaque to Kubernetes, now transparent. So this means that components like Kube scheduler and cluster autoscaler can uh, like work more efficiently. Uh, DRI also now supports versions queue with kubelet. So kubelet can be running on one version, and the control plane can be on a different version, and that is uh, that is supported. And the original DRI driver controller, which is now called the classic DRI, is still supported, but it is planned to be removed in a future release. Yep, that's all.
Excellent. Next one is support for image volumes. This is in alpha, and it's also a feature that I'm very interested in personally and find quite exciting. So with this cap, essentially what you're able to do is you need to enable the respective feature gate, and then you're able to specify as a volume source a separate OCI image. This is great because essentially it allows you. Let's imagine that you use cases where you're deploying a machine learning model, and then you want to change some of the weights. These weights can now come from an OCI image rather than somewhere else. Or you can imagine the situation where you're a security engineer and you're using a specific security tool, and then you want to load in private signatures or malware threat signatures. So you're able to do that by just specifying the OCI image that contains these things. So as I said, this goes to alpha, and it's quite an exciting new feature.
Yeah, exposing device health information through port status is also another KEP that is closely related to DRA. And essentially, what this KEP adds is previously, if you were having a device attached to a pod uh, whose health you wanted, like if you had to monitor the health of a device which is attached to a pod, you'll have to use the pod resources API, and there was no straightforward way to know if a device that is associated with the pod has failed or not. But this KEP basically adds a new allocated resources status field to the KEP status, with which you can do this more easily. And the device health information is like conveyed more efficiently with this new field in the pod status.
Awesome. Next up is FineGrain Authorization Based on selectors. This also goes to alpha, and it's another great piece of work from CGroup. Essentially, this allows webhook authorizers to allow list and watch requests on specific fields on a resource. So basically, you can then limit the resources that you want to list or watch on based on specific values on their fields, which was not possible in the past. This is already a thing that can be done for, let's say, secrets or for standard objects. Another similar work that is related is the custom CRD field selectors, which goes to beta in 131. So this, in general, is part of some great work that is happening from CGroup to ensure proper RBAC and better fine-grained authorization access in a Kubernetes cluster.
Yeah, this KEP basically allows cluster admins to specify which all endpoints can be accessed with anonymous API access. So the idea of the KEP is that with this new feature gate, you can make sure that only like health check endpoints are allowed to be accessed via anonymous access, and all the other endpoints are still uh, it still needs to go through authorization, and this like doesn't allow anonymous access. So yeah.
Cool, and that is for the major themes of the release. First of all, I'm seeing some comments about specific features that we talked about and we already passed over. Just a note that for all of those, we have linked the KEP, where you can go into a lot more detail about each specific feature, how it works, how it's documented, and all of that. And also, the presentation will be available afterwards, so you can go over that again. With that, let's spend some time to talk a bit about some deprecations and removals from the Kubernetes 131 release. The first one is CGroup V1, goes in maintenance mode. Essentially, cgroups are the kernel mechanism that Kubernetes uses, the container runtime of Kubernetes uses, to essentially allow specific containers access to very specific, let's say, resources from the system. For example, limit how much memory it can use, how much CPU time, and similar things. CGroup V1 support goes into maintenance mode, and people should start moving towards CGroup V2. Maintenance mode means that important security fixes will obviously still get fixes, but no new features are planned. CGroup V2 support should be available in most modern operating systems for a number of years now. So you are very much recommended to start moving towards that. And in case you have any troubles, where you shouldn't, but in case there are any, please reach out and create issues so that the community can work on them.
Yeah, this is a note about SHA-1 certificates, certificates generated using SHA-1 hash function. So after Go 1.18, the crypto library started to reject certificates which were basically signed with SHA-1 signatures. And if you're still using these certificates in your Kubernetes cluster, you might face issues with them. And if you still want to explicitly run them, you can add this environment variable of go debug SHA-1 that is given in the note. And with that, you can like run these certificates right now, but it is recommended that you move away from them.
Yep. Next one is a deprecation of the status node info QProxy on node objects. Essentially, this field was being set by the kubelet since a very long time ago. But since it's set by the kubelet, then it's not really the right version. It was always just informative as a field, and it wasn't exactly the right information that one might be looking for. So it is currently in progress of getting deprecated and removed in a future version.
Yeah, the next deprecation is has got to do with the in-tree cloud provider code. So historically, it used to be that all the cloud provider specific code was shipped along with the Kubernetes code base, and over the years, we've faced issues with the release frequency. So if a particular cloud provider has to ship something new in the logic with how Kubernetes is linked to that particular cloud provider, historically it had to follow the Kubernetes release process, but there has been an effort to move all of these cloud providers out of tree and have them maintain their own release cycles and so on. So this release saw a lot of code removed from the Kubernetes code base and made improvements in this front. And we have a bunch of feature gates right now in order to not have the in-tree cloud provider code run with your Kubernetes code.
Yep. Another thing also to highlight on this particular thing is that these cloud provider integrations have been long deprecated. You should already be using the external out-of-tree providers that Cyril mentioned. The biggest benefit, I think, is this exact thing that the improvements and new features in those integrations decouple themselves from the release cycle of Kubernetes itself, so they can basically work faster. And the second important thing is that all of those dependencies as code, as like repositories that Kubernetes depends on, basically go away. So it helps a lot to clean the Kubernetes code base and have a lot less let's say, surface for dependencies that need to be kept up to date, and they're dependencies that you need to keep an eye out for security fixes and all that. So this is great work to see happening. Next one is the removal of SFFS and self-RPD volume plugins. This is, again, a similar story with cloud integrations. Pretty much, if you need to use Ceph or SFFS, you should be using the Ceph CSI providers. And if these are also long deprecated and are removed in 131. If you are depending on those, you would have to redeploy your applications, obviously. But it has long been suggested that people move away from those volume types and instead use FCSI.
Yeah, the last deprecation that we have is similar to the previous one. So all the non-CSI volume limit scheduler plugins are now deprecated, and we have a list of plugins which are deprecated: Azure Disk Limits, Cinder, EBS, and all these different cloud provider specific volume limit plugins. All of these have been deprecated, and now it is recommended that we use Node volume limit plugins, which is like a general plugin which has the same functionality but works with different CSI drivers to get the same functionality. But all of these previous all the different plugins which were dealing with non-CSI volumes have been deprecated, and it's recommended that you use the generic Node volume limit plugin.
And that is all. Thank you all. I don't have anything else to add other than thank you for being here. So I think it's time for questions, if there are any.
Yeah, we have several questions already in here. Some of them are asking for clarifications that I figure you all might know or might not know, and you can direct them accordingly. But one of the questions was, I should just show this on screen. What are the specific improvements to ingress connectivity in Kubernetes 1.31, and how does stable improvement of QProxy impact network performance and reliability?
So for this, well, obviously we cannot go into technical details that are related to this. Probably the best place to figure out more about how the stuff works is going into the enhancement issue that is linked here on the slide, which is GEP 3836. The idea behind it is that, especially in environments where there is a cluster autoscaler, so nodes can come in at any point in the cluster, or most importantly, go away from the cluster at any point, because the cluster is scaling down because the load is not as high as it was. With the work from this GEP, essentially, what happens, what the Kubernetes core can do is that it can know when a node is going to be moving away. It knows when a node is terminating. So it can do work where it properly drains any connections from load balancer services. And there's even extra work where there is a liveness endpoint in QProxy itself. So external load balancers can query that liveness endpoint and start forwarding new connections to other nodes instead. As well as, if I'm not mistaken, some documentation work around how cloud providers can essentially follow this process as well and make sure that connectivity is more reliable. And what does more reliable mean in this case? Essentially, it means that when you are scaling down a cluster, you will see a lot less dropped connections. The connections will be properly drained and forwarded and moved to a different node that is still servicing the cluster, rather than being dropped because the node went away without any. That's the idea of it. But I'm not the technical expert on this. I think if people are interested in details, they can go into the GEP and basically read. This is. I really want to say that this is some great work that is happening from SIG Network.
Awesome, thank you. Another question was, and this could be a simple one, was explaining a little bit more about like device health inside of the pod and what that means and what that feature is.
Sure. So let me go into that as well. Right. So with Kubernetes, the simplest, the easiest like requests and limits that people know about are CPU, memory, stuff like that. But there are many situations where Kubernetes is used, and there are specific like hardware accelerated devices that are used by the pods. With this API, essentially, what is made possible is that you can see the status of those devices from the status of the pod itself. So when you do let's say, kubectl get pod, and you look at the status of the pod itself, it will have a field that says, I'm using this device, and this device is healthy, or it's not healthy because it went away from the system, or the driver is malfunctioning, or stuff like that. I cannot, again, the specifics are in the cap, but this is how people should think about this feature.
Great. The other one seems that I think it's a fairly simple question, but I'll throw it out there. Is does the CGroups V2 need systemd and not CGroup FS?
That, unfortunately, I'm not informed enough.
That's what happens. So for those who aren't familiar with this, because Kubernetes is such a big project, not everybody knows every detail. So that's why these enhancements and KEPs are linked. And I'm assuming that's correct, Angelos, about that's why all these are here, because then you can go talk to the people who are working on this directly. Okay. Any other questions? That seems to be most of them from the chat. I'll give people another minute or two to drop any in here if they have any other questions. Okay, I'm not seeing any more come through. So as we get close here to wrapping, I just wanted to give a huge thanks to the release team here for the presentation and for all their work in getting this out. It takes a lot of work to do these things. So as someone who works in this community quite a bit, I'm always very glad we have people who are doing this for us. So we'll go ahead and wrap this all up for right now. And remember, this will be posted on the CNCF community site, as well as you can replay this on YouTube as well. So they should be on later today, and we're looking forward to seeing you at a future CNCF webinar. So have a great day, everybody.
Thank you, Taylor. Thank you for hosting. And another shout out to the release team for all their great work for the Kubernetes 131 release.